Hey guys, so today we're going to be looking at polynomial regression, and we're basically going to be looking at how you can manipulate the graph and such. So here we go. Alright, so today we're going to be looking at polynomial regression, and as you know, last time we looked at linear regression. So it's basically a continuation, and again we're referring to W3 schools. So the first thing that we're doing is importing the models that we need, and after that we have the x values and the y values, so all of the data points that we have. Then this line 6 to 8, I'm basically breaking what we have in line 9 so that we can go through it more individually. And then over here, we have my line where we're basically making the line, and then the scatter plot, and then we're plotting. So we'll go through it in more detail. If I just run it first. So, yeah, as you can see, this is the graph that we're getting. So you can see how the values are stretching. So in the x, we were going from 1 to 22. You can see that it's going from over here, much before 5 to a little bit over 20. So 1 to 22. And on the y-axis, you can see many repeating numbers. And you can see 100, 90 is repeating, 99 is repeating, 70 is repeating, 60 is repeating. So on the y-axis, plenty of numbers are repeating. And these are basically your x and y values. And this is what the polynomial graph looks like. So you saw that in the linear line, or in the linear graph, there was a straight line, and the polynomial is obviously curved. So here we're doing, the first thing that we're doing here is making the x and y values. Then this line over here is basically that this is the one that's making the actual polynomial model itself. And the reason I've broken it in so that we can see how each of the line looks. So this polyfit thing, so this degree 3 is basically which degree. So if I make it, for example, degree 2, and if I go over here and make this degree 2, and now if I run it, then you can see the curve changed quite dramatically. So, and another thing you can observe is over here, we're getting power 2. Yeah, this is a power, basically. I know it looks a bit weird, but that's just how it's getting printed. But when we basically do print this line, poly1dA, then we're getting the equation of the line. So basically ax squared plus bx plus c, that one is equal to y, or is equal to 0, and or basically is equal to y. So here, when we do degree 2, then you can see that we're getting x squared as the largest, then x, and then 94.02. Now if I just make it 3, and I've not changed this one, so the graph will still come out the same. But as you can see over here, ignore the graph. As you can see over here, now we've got a cube, then we've got a square, then we've got x, and then plus 13.8. Now if I make it 4, then it's going to give us to the power 4, then to the power 3, then to the power 2, then x, and then to the power 1, and then the constant. So yeah. So the more your degree is, then that's how that's basically going to be the first power, and then it's going to go down from there. And basically these are this is the equation, and then these are basically this is basically what we get when we're printing A. And after that, we have, so basically then we're specifying how the line is going to display. So we're starting at position 1, and then we're ending at position 22, because on the x-axis it's stretching from 1 to position 22. And basically the 100 is that we're going to have 100 different values of it on the graph. So the first position is 1, the last is 22, and then the number of values. Yeah. And after that, we're drawing the scatter plot, which we've already gone through. So that's basically the small dots you see on the graph. And then we're fitting or drawing the line of the polynomial regression, and then just displaying the diagram. So that's basically how you do a polynomial regression.